Hi everyone, and welcome to the next episode of Gregor Theory. Today we will focus our attention on consciousness. As we have already mentioned, understanding the essence of consciousness is one of the greatest scientific challenges of our time. Consciousness is not only present in our everyday decision-making processes, but it forms the framework of our inner reality. Because it is unobservable, it is difficult to define or to describe. Consciousness plays also an important role in relation to physics. We have mentioned in the last episode that physicists still need to define the role of the observer in relation to the object of observation. Humanity has had many attempts to explain consciousness. For example, orchestrated objective reduction is a biological philosophy of mind that postulates that consciousness originates at the quantum level inside neurons. Other more conventional view is that it is a product of connections between neurons. But the mind is not just consciousness. As we have tried to show in previous episodes, the mind consists of other parts which, together with the consciousness, define the creation of thoughts and handling of external inputs of reality. At this point, I dare to say that consciousness has not yet been understood because it is necessary to focus on the complexity of the whole system of the mind. At the very top of its tasks is processing of external objective reality into a form of inner mind reality, which we as observers create. These two realities are not identical, but there is a system that allows us to process external information into a form that is understandable to us. And information is a common factor for both of these realities. Knowledge of the processes of creating and storing information in consciousness versus the way information is represented in objective reality will allow us not only to understand mind, but also to perceive the reality around us more deeply, thus enabling consciousness or intelligence to develop even further.
What are you seeing behind me is a simulation of two layers of memory. The cubic objects being carriers of information. The green layer is representing the inactive information and the blue layer the activated or active information. These information could be also called memory elements. The two layers are separate. Active or conscious process takes place only among the elements in the blue layer. The subconsciousness, on the other hand, is responsible for activating certain memory elements from the green layer and initiating them into the active blue zone. We can see that the overall number of all memory elements is larger than the number of the blue active elements, which means that in each second we work only with a small part of our memory. Now let's talk a little more about the shared memory or shared memory set. In mathematics, set is a well-defined collection of distinct objects. A memory set is a set of objects where each element is represented by a single information. In mathematics, the arrangement of the objects in the set does not matter, but this is not the case with the memory set, as the arrangement of information inside the set is very important. It is not just the individual elements that create the information but connections between these elements inside the set that create extra or added information, which we will call information patterns. We must realize that our minds work constantly. Mind processes information through consciousness and subconsciousness. We have already mentioned that the conscious process creates new memory elements, or in other words, constantly increases the number of memory elements. So on a theoretical level, the number of elements of memory will after some time approach infinity. But in reality, this is not possible. Now let's take a look at the theoretical evolution of a memory set over a period of time. We start with an empty set with no memory elements. If you look at the different mathematical theories, you will find a lot of information about set theories, paradoxes of sets, axioms, and subsets. If you look at our information objects or cubes, they too can be considered subsets of an initial set of information. First, we have to create initial segments of the main memory set. An initial segment is a single information and also a subset of memory set with a certain rank. For example, the empty set is assigned rank 0, while the set containing only the empty set and one information is assigned rank 1. We will get a growing number of subsets of rank 1 over the period of time. But it will soon be clear that the number of these subsets is not infinite, as the memory, or better to say the capacity of memory, has its physical limits. Let's presume that the number of elements of rank 1 is constantly increasing. We have a linear graph that shows the relation between two quantities. The first is time, and the second is the number of memory elements of rank 1. A linear graph forms a line and is denoted by an equation y equals m times t plus c, where m is the gradient of the graph and c is the y-intercept of the graph. T stands for time. T goes from 0 to infinity. We have to start at time 0, which means there are no elements before point 0, and thus c is also 0. Now let's substitute 1 for m, which means the gradient is 1, or it is a ratio of the difference of y coordinates to the difference of t coordinates. So in each time unit we add one memory element of rank 1. Calculating value of y with respect to t by using given linear equation, we can plot a graph as shown here. Obviously, in this case, we would have to have an infinitely large memory capacity, which we do not possess. The other case we could have is to simulate memory with something like a logarithmic function, where the gradient is slowly decreasing over time, approaching certain limit in the sum of its elements. With this equation, y equals ln of t, we would get a graph like this one. Again, we have time t on the horizontal axis and the number of memory elements of rank 1 on the vertical axis. We can achieve some sort of limitation on memory elements, thus allowing the memory capacity to be a fixed number. But that would mean that the memory elements of rank 1 that we process at the different times are not equal. So can we accept the fact that one memory element of rank 1 takes up more memory space than the other? We have to build this theory on certain postulates. For example, all information of rank 1 must be equal. This type of information could also be referred to as axioms, as they are to serve as a premise or starting point for future information patterns. So the main question is, how can we increase memory elements and at the same time keep the limitations for memory capacity? There could be two solutions for this problem. First is that we don't need to constantly create new memory elements. Instead, we can recycle already existing information that was created in the past, and thus we enable the mind to take a break from the creation process while keeping the consciousness active. For example, in a single discrete time, t1, we create new information, and in next discrete time different from the previous, let's say t20, we recycle the same information. We can connect information to a certain object, and we can assign again this same information to a similar object in the future. So this is called activation, and it is done by subconsciousness, which we already talked about. The result is that the number of elements of rank 1 is increasing in slower rate as before. It seems like this could solve our problem of memory capacity. We create memory elements of rank 1 of the same size, but the frequency of creation of these elements is dynamic or adaptive. It slows down with time and could eventually lead to a model in which the closer to the capacity limit we get, the longer is the time period between creation of two new elements. Mind age certainly plays an important role in human lives. As we could also see on this graph, it has a negative effect on our intellectual development, as the older mind can recycle more of the old subsets of information instead of creating new ones. But our main goal is to bring a memory to a higher level or to evolve the mind constantly without limitation. This means that we could still create new memory elements at pretty high frequencies even in older ages. So the solution which enables consciousness to be active and thus creating new elements all the time is to create information subsets of higher ranks. This means not only to create new elements, but also to create new connections between the elements of rank 1. Connections and information are considered equal, and so by connecting more than one information to one object, we can assign a different number of information or different ranks of information subsets to a single object. We can create information without the need to add a new element into the memory set. We only create connections to elements, and we will call this process creating of information patterns. Now, it is important to understand the whole process of memory evolution. As soon as we have sufficient amount of subsets of rank 1 or axioms, we can start combining these elements together and forming new subsets of rank order 2, 3, and higher. This is happening along a certain time scale. We understand things in more complex view. We are enhancing our definition for a single object by connecting different information that somehow are related together with the object of observation.
Now let's look at the conscious part again. The consciousness creates new elements of rank 1, but it is also responsible for creating new connections between elements and thus creating new subsets of higher ranks. So the mind captures a new object from the objective reality. The actual conscious layer is at the very moment made out of past activated information as well as newly added or real-time information. This is the environment where the new information is being created. If we consider the creation of connections of subsets, we can see that the patterns could be also made out of combination of multiple elements of different ranks. It also means that these connections connect together the past and present information into one unit. So the new created information pattern contains some old elements and some new ones. We have to realize that the activated past information affects the process of creating new information as it becomes a part of its definition. This is happening because they both share the same active layer. Thank you for watching. I hope you enjoyed this video, and I'm looking forward for the next episodes. So see you next time, and bye.